In this video, we're going to look at rational functions. And a rational function is just one function divided by another function. So it can be written as g of x divided by h of x. In SL, we're only dealing with one linear function divided by another linear function. That's why our rational function formula can be written as f of x is ax plus b over cx plus d. So what do rational functions look like when you draw them? Well, I've drawn a set of axes and a red vertical asymptote and a green horizontal asymptote. So they can look in two forms. So the first one, they'll come down, never touch the asymptote, or go like this, so along, background, never touch the asymptote. So that is one way they can look. Or the second way they can look is in the other two quarters. So up here, never touching the asymptotes, and up and along there. So whenever you see a rational function, they will look either like the left-hand graph or the right-hand graph. Rational functions all have four key features that you need to be aware of. So for any rational function, f of x equals ax plus b divided by cx plus d, the y-intercept always occurs when y is equal to b over d. You could remember this, but it's better if you understand where it comes from. Well, we know that the y-intercept occurs when x is equal to 0. Well, if we put x is equal to 0 into our function, we would get f of x is equal to, well, x is 0, so we'd get 0 plus b divided by 0 plus d. So therefore, f of x, remember f of x is just our y value, so therefore y would equal b over d. The second key feature is the x-intercept. And the x-intercept always occurs when x is equal to minus b over a. Well, our x-intercept occurs when our y value is equal to 0. And from the equation, y can only be 0 when ax plus b is equal to 0. So if we rearrange that, we get ax is equal to minus b. Therefore, x is equal to minus b over a. The third key feature is the horizontal asymptote. This occurs when y is equal to a over c. This is one you have to be very careful of, because if I changed my value of f of x to be ax plus b over cx plus d plus 2, the horizontal asymptote would occur when y is a over c plus 2. So this is the one where you have to be very careful of. So let's get rid of that 2. So we know that the horizontal asymptote is the limit as x tends to infinity. Instead of going to infinity, let's just use an extremely large number. So let's imagine f of x is equal to 2x minus 3 over x plus 5. Imagine that x is equal to 10 billion. Therefore, it would be equal to 20 billion, which is 21, 2, 3, 4, 5, 6, 7, 8, 9, minus 3, divided by 10 billion, which is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is basically 20 divided by 10, which is equal to 2. Well, that is A divided by C, because in this case y is equal to A is 2, C is 1, so it occurs when y is equal to 2. So you just have to imagine a very large number. It doesn't have to be infinity, but some very large number. The fourth key feature is the vertical asymptote, and this always occurs when x is equal to minus d over c. And why does that occur? Well, that occurs when the denominator is equal to 0. So we get cx plus d is equal to 0. Therefore, cx is equal to minus d. So x is equal to minus d over c. Let's go through an example. Sketch the graph of y equals 3x minus 6. So the first thing we need to do is find the x-intercept. So the x-intercept occurs when 3x minus 6 is equal to 0. So 3x equals 6. So x is equal to 2. Now let's find the y-intercept. Well, that occurs at the value minus 6 over 2, which is equal to minus 3. Now let's find the horizontal asymptote. Well, that occurs at y equals 3 divided by 1, so at y equals 3, and the vertical asymptote occurs when x plus 2 is equal to 0, so at x equals minus 2. Let's draw this onto a set of axes. Let's draw in all the key points. So I'm going to draw the horizontal asymptote first at x equals 3, so approximately there. I'm going to draw a vertical asymptote when x equals minus 2. So let's put in the values of 3, negative 2. Now let's draw in the y-intercept is at negative 3. So let's go there. And let's put in the x-intercept, which is at 2. So I think our graph goes along here, across there, and is in this quadrant here. So that is a sketch of the graph y equals 3x minus 6 divided by x plus 2.